When we are using the processor called Arduino, we have to connect some of the sensors and then we have to connect some of the actuators and through wireless. As I already shared videos like for the Zigbee, Wi-Fi and Bluetooth, we have to connect Wi-Fi devices or wireless devices and will communicate to other wireless devices. That is the main concept of an IoT. Correct. So here we have a lots of processor in the market called Arduino, Raspberry Pi, BeagleBoard, etc. But for the basic purpose, we'll start with a Arduino device. Practically, this Arduino device is not available in this Proteus. So to get an Arduino device in this Proteus, what you are supposed to do is you have to take a library called Arduino, a library for Proteus. I'll send you this library also. And then whatever these two files it is there. See here, I have an Arduino library for Proteus zip file. When you extract this, you will get this folder. Inside that, you will be having Arduino or tep.idx and Arduino tep.lib. These two files need to be copied to a folder where you are installed your Proteus. Usually Proteus will be installed in a path program files and in that you will be having a lab center electronics in that Proteus 7 professional. Inside that you will be having a library folder. There you have to do just a copy paste over there. That's it. So then you launch your Proteus. Okay. So the installation of Proteus and the library, I will send you that link, and even the Proteus software, I will also the zip file I will send you. Okay, either through a mail or through your Google Classroom, I will send it. Next, what you are supposed to do is you have to take a one Arduino device and then you have to say for example I will do a blink LED project. In that, I will take on one Arduino device, one LED, and one resistor. So if I do the hardware configuration, I have to write the code. Correct. So for writing the code, you should require an Arduino software also. That is, this is an Arduino IDE. This Arduino IDE also I will be sending for you people. So you have an Arduino IDE where the basic programs are already available. No need to worry about that basic programs. So you have to take that basic program and then you have to dump it in this Proteus. Okay. Now we'll see one by one. The first step is I have to create a project. So I'll go for the file, new design, take a default and then click OK. So this is your thing. So for a blink LED, what and all components you require? One is an Arduino, another one is a resistor, and the third one is your LED. That is, you have to blink an LED. So we'll select those components. How to select? Just right click, place components from library. Okay, place components from library. In that, there is an option called keyword. There you type Arduino. So you will get Arduino over here. In this, there are lots of Arduino. The simple one is Arduino Uno. Okay, select Arduino Uno. When you select the Arduino Uno, it will come over here. Along with that, you need some other components like resistor. I'll take a generic resistor and then what you want an LED components library LED, just type LED And there you can see lots of LED. I will take a simple one, animated LED model, yellow color. You can take red LED, green LED, blue LED, or a generic light emitting diode, anything you can take it. So here I will take yellow LED. Click OK. So it is being listed over here. And then right click. Again, what you want a ground here. So I'll take a ground also. So this ground is okay. Okay. So now we'll see one by one what and all we are supposed to place. So here components. See here. Can you see this one? There is an arrow below that. There is a component mode. If you go for component mode, you will get all the components whatever you wanted. Okay. Next, this is your working area, so you have to place here itself. So how you can place here? You can use a zoom in, zoom out, and if I want this only to be centered, select it and then point over here, it will become center. If you want expand this one, you click control and then in the mouse you can go upwards, it will get expanded. Okay, now first I will place Arduino. Just click on Arduino and then place it here. Okay. So I'll just zoom it to tell you what and all this Arduino have. Again, center, I want to do a center. See, if I click on somewhere here, it becomes center. Okay. So what and all the Arduino have? Arduino have some of the pins which is a digital pins. How you will identify it as a digital pin? You can go to an Arduino pin diagram and check. But generally I will tell you the digital pins are from 0 to 13. These are all the digital pins. And then the analog pins are A0 to A5. So these are all the analog pins. Where you are using digital and where you are using analog. For example, a device which works only for 0 and 1, there you are using digital. For example, LED. LED on and off I can make it. Whereas analog device, where you can use analog, for example, a motor need to be connected and it should be rotated. Or there is an LDR, need to be sent or need to be received some of the physical environmental data. There we are using analog pins. Now we are using digital pins, so I will take this pin number 13. Next thing is you have to take red yellow or sorry LED yellow. I'll select and I'm going to place it here. So in a LED or in a diode, here LED what it does, it's a light emitting diode. So diode will have a two pins, one is a cathode, another in one is an anode. Usually when you select a physical device, what happens is the longer one will be a cathode, that is a positive terminal, and shorter one will be the anode, that is a negative terminal. So positive terminal, I have to connect to a one digital pin. Usually, the 13 I'm supposed to connect. How to connect it? Just press on that pin. You will get a red box. Click over there and drag it where you want, and then whenever you will get that red box, you click OK. Okay. Next thing is you have to connect a one resistor. So I'll take a resistor. I will place a resistor. Okay, this is not possible. Okay, need to connect or it is clumsy. So usually, sorry, this one I have to delete. Uh, where is the delete option? So no, yes, no. No, edit. Okay, I'll just do undo. So between LED and that pin, you are supposed to connect a resistor. So I'll place a resistor here. So usually for LED connection, you should not have a 10K of resistor. You should have some minimum one. So I have to reduce this. How to reduce? Right click, edit properties. Rather than 10K, I will just take 1000. That means 1K. Okay, if you take 10K, you will not get to know whether LED is on or off. Now from the 13th pin, I will connect to a resistor. From the resistor, uh, from the LED, I will connect to a resistor. Okay, next, from the anode, you are supposed to connect to the ground. How you will place the ground? Just right click, place terminal. In that you will be having a ground. So I'm going to place somewhere here and then I will connect it. Okay. So this is the physical one, you have done it. Fine. So now I have to dump a code for an Arduino to blink this. So how to dump a code for an Arduino? For that I have to go for Arduino IDE. In this Arduino IDE, just take a file, new or example, if that is a inbuilt availables are there. You can take a basic in that blink. Okay, so this is a blink LED part. So here what happens or how to write a Arduino program is you will be having a two function. One is a setup function, another one is a loop function. In the setup function, I will say the pin mode. For example, LED button is a inbuilt. Even I can change it for a 13 because I'm connected to a 13. So I can say LED 13 and make it as output. So from the Arduino, I'm sending 0 or 1. So that is what the setup will do. It will initialize the inputs and outputs. Whereas in the loop, it will say what the spin will do. Say for example, digital write LED built in. Okay, usually built in rather than built in, I can use 13. Okay, so here also I can use 13 because I'm connected my LED to the 13. First, I will make it high, so which turns on an LED. I will make a delay for an 1 second, then I will make it low. So this loop will infinitely run, continuously it will run. Okay. So once you have written the code, you just verify it. Okay, there is an error exists. Okay, I have to make it new because I'm changing the inbuilt one. So I'll take a new. I will just copy. I will save it in the new one. Then I will verify. So I will save this somewhere onto the desktop. Anywhere you want. I don't want this file actually. LED save. Next verify. See here. This is done. When you verify, it will sketch users to say 928 bytes of program storage space. Something it will say and it will be saying in the white one. That means there is a no error. Once it is done, I want an hexa file for my Proteus. So where this hexa file will be generated usually. So I'm doing a virtual. So it Arduino doesn't directly give the hexa file. So I have to see where that hexa file will be written. So how to see that? Go for Windows, then type run. Next, in the run, use temp. Remember, in the last laboratory also, we have used a temp file. So click OK. In that, just check the present timings, say 7:26 almost. So in this, I have built one code, and then I have this blink ino dot hexa file. Not blink dot ino dot hexa. I think not this one. What is the timings right now? Yes, this one, 17:27. So here you will be having led.ino.hex. What is this LED? LED is the name of your Arduino file, what you have created, followed by you will be having an extension called .ino.hex. So take this path. Okay. So take this path and then go over here. Proteus, you have to switch to the Proteus and then double click on Arduino. Okay, there it will ask you what is the program file. Copy the file extension. See here you have only copied the file extension but you haven't copied the full file. So what is the full file name? Uh, so here dot hexa file, uh, rename, copy, go for Proteus, control. See, this is the complete extension of your .hexa file where it is present. Then click OK. So your program is ready, LED is ready, and the resistors have been connected. Now you have to simulate it. So how to simulate? See at the bottom you will be having a one play option. Just give a play. See, can you see the difference? The LED is blinking. Okay, so this is how you can virtually demonstrate any Arduino kind of devices along with the sensors or actuators. So this is a simple example. Okay, if I want to pause, I'll just pause it and then I'll give an execute. So this is just connecting to a LED. Next, we'll see one more thing, how you can do an advanced one. So this is already been written by me. I'll just open the design, open this file open. Uh, in E drive I have saved LDR design. So what this LDR is doing? In this, LDR is what? It is a light detecting resistor. Whenever light is being detected, the resistance value will get changed. So based on the resistance values, my LED should on. Where this application will be useful. Say for example, I have placed an LDR in front of my room. Okay, if somebody enters into that room, at the starting of the room, the light will get either dim or will dim. That means either it will the light will go down. So that will be detected by this LDR, that is light detecting resistor. So here I have placed a light, and then how to place the light? If you select the LDR, automatically it will select the light along with an LDR in the protest. So when you have selected an LDR, so there are two terminals. For one terminal, I have given a supply. How to give a supply over here? Just right click, place component from not component terminal, and then power. If you select the power, you will get this supply. Okay, right now I don't want this. I'll just delete it. So how to delete? Select that part and then press a delete. Next, I have selected a one resistor which is of 1 kilo ohm, and then again a 13th pin LED is connected to 13th pin of Arduino. See here, LDR, what it will write, it will actually write the analog value. So how it will write? It will just write the vary of a resistance based on the light it is entering. And what is the code for that? We'll see what is the code for that. See here, LED I have selected for 13, and wherever I am using the 13th pin, I am just saying it as an LED, not the 13th pin. Next, there is a serial begin. Why serial dot begin is used? Because it is giving an analog value. LDR is giving an analog value. So to capture an analog value from any outside device to the Arduino, we'll use the serial dot begin. That is serial dot begin followed by baud rate. So usually most of the analog devices will capture a 9600 baud rate. That is per second it will send 9600 bits. So this is for an LDR to capture what it is writing. Next, in the loop, that is loop will do what? It will do infinitely. It will run infinitely. So in this LDR, from where you are capturing analog read A5, you can see the structure of Arduino. For A5, I have connected this LDR. Okay. Next, what it LDR is doing? I'm capturing an LDR through serial.println. That means you are printing on to your Arduino IDE. So Arduino IDE in the sense you are taking an input from that, and for every delay, that is a half second, you are taking an input. If the LDR value is greater than 512, then you are writing to a LED. Digital write to LED means you are writing a 1 to LED. That means LED will on. Give a delay. Else, if LDR value is less than 512, you are making LED low by writing LED low. That is 0. So this is how the loop works. So same thing we'll say here. So the LED light is somewhere far from the LDR. If the light, I will make sure that it comes near to the LDR, then the LDR will detect and it will change its resistance and it will start writing to the A5. And based on what it has been written to the A5, if the value is greater than 512, we are writing 1 to the pin 13. That means LED will go on. If LDR writes below the 512, then LED will go off. So how to do that? Again, you can go for LDR, just verify. Once you have verified, it will come and sit in your temporary file. This is your temporary file. Somewhere here I have written that. So go over there, see LDR AR underscore INO dot hex file. Copy this path and then put it over here. Okay, how you put it over here? Right click, edit properties and give that path. Okay, click OK. Usually you should remember that I have kept that in a temporary file, but the temporary file will erase it once you shut down your system. So it's better you keep it somewhere onto the desktop and then give that path. Once it is done, you just give a play. So right now it is working, but LED is not on because LDR value is not greater than 512. How to make LDR value 512? By pressing the plus button, the light will go near to the LDR. See here, light will go near to the LDR. When the light goes near to the LDR, LED on. Next, when the light comes far from the LDR, light will automatically off. So this is a simple concept where you can say that LDR is connected to the door. When somebody enters, based on the light value, you can send a message to through a mobile phone saying that somebody entered to the room. That is on one application. The second application is, assume I want to count the number of members who are entering into the conference. Then what you will do? You will put an LDR onto the door of a conference room. So based on the number of times the LED or the value goes down, you can say that these many number of persons enters into the conference hall. So this is the basic example of Arduino with a sensor. Okay. I'll just, can you people unmute yourself? Please unmute yourself.
Yes, ma'am.
Yes, ma'am. Okay, fine.
Yes, ma'am.
So any doubts? Can you do it?
Ma'am.
Yes, ma'am.
Yes? Okay, fine. So I will be assigning some of the assignments for you. So based on that, your final CIE 10 marks will be evaluated. So what you have to do is, first thing is you have to create the same thing whatever I have done. Arduino interfacing with Blink LED, maybe 27. I'll just add an extra one more day. Then you have to submit in my Google Classroom. Just give a screenshot of it. Next, Arduino interfacing with the LDR and LED. Again, whatever I have showed you. Okay, I'll just stop the recording.